Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson about synthetic rubber. In the last lesson, we learned about the three condensation polymers called nylon, polyester, and bakelite. Today, we will study synthetic rubbers, such as neoprene, butyl rubber, and styrene butadiene. Are you ready to begin, students? The term synthetic rubber describes any type of artificial elastomer. An elastomer is a material that can undergo much more elastic deformation under stress than most materials and still return to its previous size without permanent deformation. Synthetic rubber can be made from the polymerization of many different materials. Some of these materials include isoprene, 1,3-butadiene, polyurethane, fluorosilicone, chloroprene, and isobutylene. These monomers can be mixed in different proportions according to the properties that are desired. The resulting polymer is often better suited to its task than natural rubber. Synthetic rubber was first invented in the late 19th century, when the expanded use of motor vehicles increased demand for rubber. Scientists working in England and Germany succeeded in polymerizing methyl isoprene in 1909, producing the first completely synthetic rubber. By 1925, the price of natural rubber had increased to the point that many companies started exploring other methods of synthesizing rubber. The outbreak of the Second World War increased demand still further. The result was that the production of synthetic rubber became a major industry. It is time for our first activity, students. Let us see what you have learned. What are some of the monomers which can be used to make synthetic rubber? Please list as many as you can.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. How many were you able to list? The monomers we have learned so far are isoprene, 1,3-butadiene, polyurethane, fluorosilicone, chloroprene, and isobutylene. I'm sure that you were able to remember these monomers. Good work. Neoprene, also called polychloroprene, is a family of synthetic rubbers. It is a linear thermoplastic polymer. Neoprene is chemically stable and remains flexible over a wide range of temperatures. Neoprene's chemical inertness makes it good for industrial applications like gaskets, hoses, and corrosion-resistant coatings. It also has a wide variety of commercial applications: orthopedic braces, clothing, weather stripping, and even jewelry. Neoprene can also be foamed and used as insulation in wetsuits. Here, we see a blimp that has been filled with the element helium. The interior of the blimp is coated with a sheath of neoprene, as it is flexible enough to stretch with the gas, but impermeable enough to contain the tiny helium atoms. Let us pause for a moment and do another activity. Students, can you write the chemical equation for the polymerization of chloroprene? Please go ahead and do this now. I will see you in a few minutes.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, everyone. Here is the chemical equation for the reaction that results in the formation of neoprene. As you can see, chloroprene is the other name for 2-chloro-1,3-butadiene. Through addition polymerization, it becomes neoprene. Does your chemical equation look like mine? I hope so. After the class, compare your equation with those of your classmates to make sure that everyone understands the reaction. Another synthetic rubber is called butyl rubber. It is a copolymer of isobutylene with isoprene and is formed through addition polymerization. Butyl rubber can range from colorless to light yellow and is generally odorless and tasteless. It is very flexible. It also has outstanding impermeability, which means that it is airtight and watertight. Therefore, butyl rubber is often used when an airtight rubber is needed. It is used as an adhesive, an agricultural chemical, a sealant, in fiber optic cabling, and in paint. It is even used in chewing gum. Styrene butadiene rubber is a copolymer as well. It combines styrene with butadiene through a process called addition polymerization. Styrene butadiene has better mechanical strength than natural rubber. It resists abrasion and, when properly treated, remains stable over time. It is widely used in car tires, shoe heels and soles, and gaskets. It is also used as a watertight sealant. We have time for one more activity, students. We have learned about 3 kinds of synthetic rubber. In groups of 3, please list as many of its uses as you can think of. You may get started immediately, everyone.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello once more, students. I am confident you were able to think of many uses for synthetic rubber. Some uses include for hoses, braces, clothing, weather stripping, car tires, shoe heels, and jewelry. It is an adhesive, an agricultural chemical, a sealant, and a primary ingredient in many chewing gums. Synthetic rubber must be a very versatile and useful material. In today's lesson, we have learned some of the monomers that can be polymerized into synthetic rubber. We learned about the monomers of neoprene, butyl rubber, and styrene butadiene. We also learned some of the properties and the uses of synthetic rubber. Teacher, please hold a class discussion to further explore the various uses of synthetic rubber. I am sure that you will make some interesting discoveries. That is all for today. Until the next lesson, thank you, teacher. Thank you, students.